decision tree regression. So we're going to start with import numpy as np, import matplotlib dot pyplot as plt, import sklearn as sk, maybe there's a better way to do this. Let's do it. I'm just going to copy it over from what I had last time, if I can figure that out. All right, so let's do an example. All right, so decision tree regression. We're going to start with train and plot the model. And so we're going to build the data, and we're just saying m equals to 200. That's just the number of data points we have. X is our data is equal to np.random.rand of m comma 1, and then y is equal to 5 times x, and y, sorry, that's a lowercase y is equal to np.random.rand n this time of m comma 1 divided by 10. So let's see if that works. Gets me a little bit of random data in the x and the y, and now I can go ahead and train a model on that. So train the model. We're going to go x underscore model is equal to np.lin space of 0, 1, 100. I need to reshape that just to get it to fit into my model of -1, 1, and y underscore model equal to tree underscore regression dot predict of x underscore model. Hit F5, and tree dot regression is not. I missed a couple lines here. I apologize. So I need to first define those. I just went straight ahead. So first we got to build the model. Tree underscore regression is equal to sk.tree.decision tree regressor. We're going to set our max underscore depth is equal to 3. And then we can go tree underscore regressor dot fit x comma y, capital X, lowercase y, hit F5, boom. Now our model is trained and now our model is fit, and I've made x and y data of my model. So let's go ahead and take a look. plt.figure, plt.plot, x comma y comma label equals data. plt.plot x underscore model comma y underscore model comma label, everyone likes a label, is equal to model. And then plt.xlabel put it in LaTeX mode, and then plt.ylabel and plt.legend, open and close brackets. We have an error, but I think that might just be related to LaTeX compiler, so I'm not going to worry too much about it. Okay, so now we have a model here that doesn't quite look awesome. We're getting it to jump around a little bit, which is perfectly fine, but we're able to train a regressor model. Probably would look better if we had a slope on this, wouldn't it? So y equals 5 times x. Why do I not? Oh. Maybe I just have way too much noise here. Divided by 100. Let's reduce the amount of noise. We are going to find a better data set here. Decision tree regression. So what did I have? 5 times x, 200.
Y plus.
What?
Y plus.
Is that what I'm missing? Oh yeah, that's what I'm missing here anyways. Okay, I had that in my example. So there we go. There's a nice regression tree. So y plus np random, that makes more sense. I had that in my notes, I just didn't type it out. So now we've got a linear regression tree that follows all the way through. And let's go ahead and plot the regression tree. And again, we're going to pull in the same data that we did on the previous example. I'm sorry, not the same data. The same export graph visualization that we did on the previous example. I'm going to paste that in there. We're going to need to change our tree from classification to regression. Hit F5. Out file. I just should have typed it out. Tree. We'll get rid of features, classes, and names because we don't need those. And then we should be able to create in our folder a nice file called tree. That is not quite what we want. Um, looks like we're not getting a tree. How am I still getting classes? Oh, there you go. I have to load the right file. That makes more sense. So now I can come over here, and I might be able to look at my tree now. Open tree dot. Huh. All right, tree output file tree underscore regression. We're going to view tree underscore regression. For some reason, it must just be sticking to a previous file. No, it's not. What's going on here? Let's do the old clear the memory. All right, should create a tree regression file. And there we go. Yep, the memory just wasn't getting cleared. And so there's our regression tree that breaks it apart for our linear data.